Okay, so yeah, so as per the agenda, I'm going to uh, give an introduction to open source 5G networks and followed by some practical demos. Okay, so yeah, so this is the agenda of today's talk. So I'm going to introduce 5G open source and then we'll spend some time introducing what is the need and motivation, what are the use cases where actually it is useful, uh, and the what are the different options, what their high level features, basic comparison, and then the very little information on cost part. And then we are going to talk about how is it different from the 5G use case lab. So then we have this. So who actually creates the OAI 5G, which is one of the open source RAN and core network? The what is the architecture of the same? Then how is the hardware and software setup look like? The little details of various features. Then the what are the details of the debug tools? What all you can do with that, whether it is industry people, enthusiasts, the academic people, or or even the professional engineers. So that is the main thing on the covering the presentation, and then we will just quickly give a how are the end-to-end setups, which are the SDR based, some snapshot, the ones which I am going to use or which I have used, and then we'll have a quick demo with the live 5G COTS mobile with the live network, desktop network using the open source, and then in the end we'll have a Q&A session. Okay, so is it fine? So basically here I think I'm not really going to talk about the technical details of the how to use open source or basically setting it up, all those logistic detail and usable use details. So those anyway, I think can get covered in some other later talk. But today is more of an introduction and what is a use and the show the demos. Okay. Yeah. So this is my quick introduction. I have done MTech from IIT Delhi in 1995. Worked in various organizations, CRL, PAL, SASCAN, Intel, TCS. Through TCS, I have worked for Viavi, which who make actually TM500. A chip design company called Max Linear in satellite broadcasting and now even in 5G. I also worked in Lekha Wireless. Through Lekha Wireless, I worked for Marinier for almost 4 years. And my last company was actually a Leapfrog Semiconductor. This is again a 5G startup. Okay, so yeah, so basically I have worked in almost all the G's of digital communication system. Most of the time I worked on physical layer and signal processing side. Yeah, but I worked in almost all the aspects. The starting from the specifications, then the algorithms, the systems, implementation, making things work in lab, the field, all that. Some point of time in early in my career, I also worked on some hardware design, hardware board design also. Again, it was for some particular communication project only. Yeah, so at present I focus on more on open source SDR based networks, and I also worked on low cost learning tool setups for open source and academic research circles. Yeah. So let's get started. So let's introduce the open source So this, I think all of you might have seen this picture. This is very simple, but at the same time it actually tells what all big actors are there. We all of us know that we have got a core network, 5G core network, then the GNB, uh, and which is also called RAN part, and then the third actor actually is the end user, the mobile, the UE, user equipment. That can be some dongle, that can be some COTS mobile, or any other device which is having a 5G modem side connectivity, right? And then if you go a little further detail the breakup, then typically the external network is like public internet. uh, that's not just exclusive, there can be a public uh, some other network also. Then we have got this 5G core, which typically gets implemented in some in in basically in some the general purpose processors. And then we have got the RAN part, CU, DU and RU. Like this is the typical architecture, CU, DU, RU architecture which is there in 5G, right? So control unit, and then distributed unit, and then radio part typically, and then the user equipment, right? So now since our talk is today on open source, so if you see in last 30-40 years, what are the major actually open source uh, revolution which have been there? You will find that there are quite a few, but notably you will find that the latest one is last in just 15 years is one of the latest one which we have, all of us have seen it very clearly, is the in the mobile phone segment, the Android, which actually is basically is based on the Linux kernel, which again has been an open source. And then of course in AI, Python, PyTorch have been quite popular. Before that, the cloud side, Linux, all the major servers and typically are based on the Linux, right? And now in 5G, the Open RAN, Open Core have come up. Now I would not call it that it is a revolution. It has revolutionized the 5G industry, but I think in general 5G industry has not really realized its full potential. So there is a last yeah. So that still has to be answered, whether the Open RAN will really go the full path. Hello, there is quite a few loud noises coming. Is anybody unmuted by any chance? Hello? Yeah. So coming to the okay. Uh, so why use open source basically for 5G? The open source basically the you I'm not really sure how many of you have used open source, but you will find that open source by nature is like a is not the full uh, the ready-made turnkey type of stuff. It's like okay, some full stuff is available. You need to really mix it properly, and then prepare it and then use it. You can customize it, do anything. So uh, during that process you are come to know what is how the system actually is behaving, why the system behaves this way, right? So the typical advantage of using an open source in our work for learning or for any other purpose is that we become better engineers, because we will not get answers in all the manuals or documentation. We have to ourselves do a lot of experimentation and try out, and then we'll also become better researcher, and then you will face a lot of problems. There will not be no customer support, so then you have to find the solution of the problems which come open source, whatever the tool or any software or hardware you use is actually is replacing any commercial company or component or any product. It basically is, you can say that the one of the major the fallout of a open source system is basically the you are replacing your ignorance. You are learning continuously and in the better way. Okay. So and then coming to the, for learning purpose, what is the motivation to adopt open source for 5G? So as all of you have been seeing, the AI actually is already replacing bulk of traditional jobs, uh, the type of jobs which are repetitive and then which can be test, QA, lot of that type of work profiles are getting basically are getting done, and continuously it is happening that those are will be getting done by the AI, right? So the whole work setup actually is moving from automated task, that typical task like certain, there is a certain way of methodology to do something. If it can be broken into steps, then it is definitely prone to the AI, right? So what basically it is forcing us to do is that, as far as engineers are concerned or the workforce of the technology is concerned, that we need to be the real masters of the work. It's not just enough to do the routine job. We have to be the master of it. Need to be more knowledgeable about so many things, and we need to know why certain thing is behaving, how to improve it better if AI is not able to do that, and how to make AI to do it better. So there is a since learning is also these days faster, so there is a need for the holistic learning. That means we need to now know more about so many things which are related to the our domain of work. More so in case of our 5G, 4G networks, which are quite complex, as you people know that there are quite a few components, layers are there, and till now every layer, typically a dedicated engineer will be there. The people will be dedicated to that particular layer. L1 will work only on L1. L2 people, Mac people will work only in Mac layer. And then sometimes they just interface, and then sometimes end-to-end issues will come, then they talk to each other and spend a lot of time debugging and solving the problems. So that actually is quite time inefficient, I would say. Uh, so that's what, that's why we need to move to the a faster and more efficient system of developing the communication networks. So another thing is that the whatever is the the software part or the implementation of the protocol of any specification which are following 3GPP, whether it is RAN or core network, they actually follow a very standard and very unambiguous type of specification. So that provides a reason, and that also is the reason actually why the load of these days the L1 L2 modules or the cellular network modules are actually getting written by AI itself, AI coding tools. And then the, as you know, the third reason is that the uh, basically, as far as learning is concerned, is that you can actually run full end-to-end network in fully simulated manner on a single desktop without spending a single penny. So I, that actually is possible. So we'll go to that, and how does that work, and we can actually learn all the advanced concepts of cellular networks, whether it is 5G advanced, NTN, the URLC features of the 5G advanced, the AI for RAN, AI, RAN, and then also 6G things are also slowly evolving. So all that is possible actually to experiment, to do research, and at the same time learn also. So the and using an open source 5G network, you can actually create a desktop radio based real 5G network to which a real 5G mobile will get attached, right? So that requires software defined radios, TASIM, and 5G COTS mobile phones. All right. So yeah. So any queries on this? Any questions or any comments? Hello. Am I audible?
Yeah, Nitin, at least nothing from my side. I don't
Okay.
have any queries.
Okay. All right. Yeah. So the use case typically are in academic research and 5G test beds, prototyping and performance benchmarking, the interoperability testing with vendor equipment. I think this particular thing is already being used by some of the commercial equipment makers. So they actually basically will have an open source reference, and then whenever they face any problem with the interoperability of their uh, network with a commercial UE, they can always go back to the open source reference and then try out various combinations. The education and training is actually, as we have already discussed, is very a major use case of this open source architecture. Then multiple things, experimentation related to network slicing and the MEC can be done. So to summarize, it provides a full self-sufficient platform to do self-learning, upskilling, and research. All that is possible. Okay. So yeah. So let's look at some of the what are the different options for RAN part. So there are not many options for the fully functioning RAN part for a 4G 5G system. We have got only handful of those. SRS RAN is quite popular, and then they have got a open source version as well as they have got an enterprise version. So they also sell it with some more advanced feature as a commercial product also. And then there is this open air interface 5G. So this one is quite popular in India as well as in various parts of the world, including the universities and so many R&D labs. Right? There is one more which they have some options in OR and SC, but that basically has got only Intel Flex RAN, and that is more of experimental. It's not fully open source, so we'll skip that. So we can say that basically we have got only two major candidates, SRS RAN and OAI 5G. Now the core network, there are more options. The OAI, the people who make who write actually the RAN part, they also actually have a core network implementation, which is again an open source, and they themselves use the same OAI core network and OAI RAN when they test and deploy their system. And then quite popular once the core network core base is there, open 5Gs. I think many of you might have heard about it. Then we have got free 5GC. There is one more SD core. So we'll not go into detail of all that. So starting with the SRS RAN 5G is written in C++. These are the features. Just give me a moment. There's quite a lot of aeroplanes are flying and noise. I will just shut down the window. Yeah, so whatever the features, hello, whatever features I have mentioned here is taken directly from the official website, and then this is what they say, uh, release 17 aligned. Now actually I have used their stack in past, not so much in by changing the code, but I have used it and integrating it. So they have been evolving, and as per their claim, they have now released 17. I'm not really sure whether it is really fully release 17, but I think I would believe that many of the advanced features of release 617 are there. So the they also, I mean, it's all bandwidth, 100 megahertz TDD, FDD. I think 20 megahertz is definitely there. I think 10 and 5 are also there. 5 I'm not sure. Yeah, as such 5 is there, but yeah, all the major bandwidths are supported. They only support 15 and 30 kilohertz. The all the physical channels. Uh, they have this the highly optimized LDPC and polar encoder decoder. All RRC procedure, MAC procedures. They also support split 7.2 using in-house OFH library. All this QM256 support is there. 4x4 MIMO slicing. NTN has been there I think for some time now. Then they also have CUDU split. They were not really having this CUDU split. I think almost 1.5 year back, but now they are having. Then, as per their the upcoming features, they use CUCP and CU. I think it should have been I think CUCP and CUUP separation, and FR2 is still not supported, and then higher order IMO, because we know that the the number of layers in downlink can go up to 8 also. So the one more thing which I wanted to mention quickly is that it is written in C++. So even though the code base is quite stable and very well written and very exhaustive, I have personally looked into it. It's these days a lot of people find C++ quite difficult, and they many of them actually are not really knowing C++. So that is one reason why the SRSN is not so popular, particularly in the academic community. Uh, then
Nitin, any particular reason like why still they don't support FR2? Because I think like at least when I was working in Capgemini, like
okay,
in the RAN side, we had FR1 and FR2.
yeah,
And that is the basic thing I
uh,
thought.
yeah, Tejaswini, but I think generally effort has been almost a complete failure. So there are not many deployments for FR2, because contrary to whatever was promised, it has not really delivered in usability also. So keep on hearing that the FR2 actually is functionality itself is actually is severely impacted whenever there are rains or various nature uh, disruptions are there. So I think because of the higher frequency, so that's the reason why the vendors, basically the vendors are not really going for FR2, because there is not enough demand. There is hardly actually any demand for FR2. Okay.
Okay.
Yeah. So
Mm-hmm.
coming to the OAI 5G, it's written in C. much more easier because compared to C++, more more people actually know C. So yeah, these are the more or less similar features. You will find that they also support 120 kilohertz FR2, right? They have already support for NTN also. Uh, they also have similar type of features as such. Only if you go into detail, you will find out what is there in one particular RAN, which is not there in another one. But more or less, they are on the same ballpark range as far as features are concerned. So the the GitLab for the OAI 5G is at this location. You can find all the documents and everything. Yeah, so the OAI 5G ran the modes of operation. These are the mode of operations. Will not spend much time. Just mention that standalone mode is the one which is used by most of the people. Okay, so now already we have discussed a bit about their differences. Is that uh, the there is general thing comment is that the OAI actually is more complete because they have got GNB as well as the UE implementation in software, which is actually highly featured. And in fact, they claim that now it is so evolved that it can actually work as a with a commercial, say for example, Amerisoft GNB. So uh, so that is one reason why the OAI 5G is more popular and it is more preferred also. And now they are and they are also having a the core network, and now they are having OEM also. So the last region which is very important, particularly for the open source community, is that their support is quite vibrant and in their emailing list, because they are the writers and the people who are at the helm of the affairs who are writing. They are all the university people, most of them, and they actually themselves reply to many of the questions almost the same day. Sometimes you get replies very quickly. Of course, there is a very vibrant mailing list, and news groups are there. So, which is this is the part which is lacking very clearly for SRS RAN. So they do have some mailing list, but believe me, I am part of both, and there is hardly any traffic on SRS RAN mailing list. Okay, so till now, any comments or uh, any query? Okay, so we'll move forward. So then the next question is that how is it different from 5G use case lab? So uh, you might be knowing that this 5G use case lab, which has been quite heard in the media also in last few years, because central government sponsored started a program to supply and subsidized very heavily to the some top 100 institutes in India, and so that actually is a closed system as such, and again it's a commercial grade, but you cannot have any, and its range will be basically for can be within a campus network which is suitable for the university campuses. So the these are the some of the differences. Again, I'm not going to dwell upon all the things. It's sufficient to say that the visibility of 5G use case lab actually is limited. It is meant for the use cases, while the open source there is you have got each the full source code, so you can basically change each and every line of the source code and do anything with it. So uh, so basically use case lab is meant for use cases for 5G connectivity, and it is no small goal, because if you see technology wise 5G has not really done well, because there have not been any real use cases for 5G advanced features or normal features also compared to the 4G. So the 5G use cases are extremely important. So that's the reason probably the government has also uh, gone ahead and started on the use case lab. Okay. So the last point I highlighted is that the stability and range. So typically the use case lab, and I know myself because uh, I work with somebody who has actually supplied the full the the CUDU part for the radio part, including radio part for the 25 colleges in North India. So it's basically commercial grade quality, and it has got 1 to 2 kilometer range, and it can work up to it is been found working for even 72 and more hours in one without any crash or without any disruptions. While the open source is typically limited to the desktop, and there are a lot of question marks on the stability, though those have been improving. But yeah, still there is a gap between the commercial grade quality and the open source 5G network quality. All right, so any questions from any of you on this part? Yeah, so coming to the again the we have been talking nicely and so nice thing about open source, but we also need to look at the what are its limitations, what are the things which you cannot do so well with an open source setup. So one thing is that it is a functional implementation. Generally it is not efficient compared to a commercial grade RAN and core network, so it requires higher computing resources. So it may not have all the features, it may have a lot of intermittency in some use, and then you may find some occasional bugs, and so many things will require refinement. So as we already discussed, it is not so much suitable for 5G use case lab, as those require a very stable 5G connectivity. Okay, so and then by nature open source is not plug and play, even though the documentation is has been improving. In fact, for SRS RAN, I have actually had experience with both SRS RAN and OAI 5G. In fact, I used SRS RAN 4G since I was doing some changes in that, and I was it was very quick for me to set it up the SRS RAN 4G, because I just followed their instruction, and which were very clear and to the point without any ambiguity. For me, it happened very fast. So yeah, so SRS RAN has been doing very well on that account. OAI 5G, they also have very extensive the documentation, and it is improving day by day. Yeah, but in general, you will find that by nature the you will require some ramp up to even set it up and use it. Okay. Yeah. So since we looked at both options and we zeroed to the OAI 5G, so now let's go into little more details of the OAI 5G. We'll look at who actually is making this OAI 5G RAN and core network and what is its top architecture. Okay, so OAI means Open Air Interface. They are basically a open source software initiative uh, developed by an alliance and mainly driven by a group in France University. The university name is Eurecom. So they actually provide a complete 4G, 5G radio access network and core network implementation, and it has been going on for last I think 10, 11 years now. I think they started probably in 2015 or 16. They started with obviously with 4G, and then once 4G worked and everything, then they moved to the 5G also. So typically they target researchers, developers, telecom companies for experimentation, testing, prototyping, interoperability test. So it's compliant mainly with 3GPP standards, release 15 and then some parts of 16 and 17. Okay, so it's a certain license type is there. They support both no NSA, SA, uh, and SAUE also, 5G NSA and SAUE. In fact, the 5G SAUE basically works with the commercial or sorry, yeah, forget it. Basically, the OAI 5G RAN has been found to work with many of the commercial core network and open source core network, the like Open 5Gs. So it typically runs on commodity uh, x86 hardware with the Linux. So the founding member is Eurecom and the strategic member. This is just some snapshot. Not I have not really included each and every one. So you will see that Ericsson is there. They have joined some 1.5 year back. They are quite a Nvidia is there, Orange, the Nokia, all these big names are there. The associate members are there. Lot of other companies. The OII box make uh, the system setups and lab gear for the using the OII. Then there are a lot of research and academic institutes. So right there ISC from Bangalore and IIT Delhi and IIT Hyderabad, IIT Jodhpur, quite a few places are there. Okay. Yeah. So basically the RAN part, anyway, all the implementations are there, and all the core network, all the all the components of the core networks are there in their own 5G core network. Then the UE, simulated UE for lab testing and validation is quite useful, and they supports uh, SDRs. Though there is a there that's where there some limitation is there, because at present they just support only the ITAS National Instrument USRP family of SDRs, and certain models of Benetel, VVDN and Lekha Wireless ORU have been found working with this their RAN. Okay, so their community and yeah,
Okay, Nitin, just one question I
yeah,
have. The previous slide, we mentioned that it supports OAI 5G supports both SA and NSA, right?
yeah,
In NSA, non-standalone, mainly we use EPC, right?
correct,
World Packet
yes,
Core.
yeah.
But here I'm seeing only 5G core here. Means how do we support NSA then?
Yeah, actually, it is not means mentioned explicitly. But
Okay,
you,
EPC for 4G.
yeah,
Okay.
you might have seen, yeah, they clearly say
Hmm.
that supports the following NSA GNP.
Okay.
And since
Hmm.
their EPC is already there as part of
Hmm.
the core network, so
Hmm.
it is supported.
Okay.
But I would say that in general I have seen that in the at least I have seen in their mailing list and the communities that most of the people are using 5G SA.
Okay.
Yeah, so there all the things, everything is available publicly. Documentation and mailing list support is there. Uh, as far as our Indian context is concerned, the iOS MCN is which is part of the which is a project running in collaboration of ISC, IIT Delhi, CDAC, uh, I think Trivandrum, and they have got a consortium of other the companies supporting companies. So they have actually you means you can get support. You can contact them also and can get some support. We'll talk a little more about ISMCN. And in general, you can always find that a lot of Indian institutes are using same, whether it is academic side or the even many commercial companies are also using. But yeah, there is a lot of scope for open source to grow in the academic and academic community, considering that there are quite a few engineering colleges are there in India. So there is a lot of scope. The this is a very top level architecture. You can find that this is the so here you can clearly see that NSA is here, gets covered here, and then this is 4G, and then this is the SA part, right? So all the CUDU F1 split is there, right? This is again a very high level module architecture. All that CUUP, CUCP, CUUP, uh, DU part, CU, all that actually is RF sim. This is RF sim basically is the simulated version. We'll talk little more about RF sim because it is very important and interesting uh, the the mode of the DU. So yes, and then of course this NRUE, the software implementation of a almost equivalent to a commercial UE side model. The core network, all the components are there. Yeah. So the Indian Initiative for Open Source, iOS MCN. So already we have discussed. So they basically one of them their main agenda and their mandate is to provide open source component for all the parts like RAN, core network, OEM, and tested with Indian ORAN radios, like they have tested with VVD and Lekha, and they aim for a commercial grade quality. They have been releasing, I think now for last 1 year or so. Their latest release is basically zero point 0.4, which just got released in the, I think the last day of 2025. They basically uses customized OAI 5G RAN. Why? When I say customized, because they have added multiple features on top of the OAI 5G, including including the various handovers and the their the the intellectual IP in the form of the MAC scheduler, and then they also have got a customization in SD core, and think they have written OEM also. So all the components are available. So the details of their release is here. Anybody who wants to look at the source code and documentation can go to these locations. Okay, so any other queries till now? Okay, like okay, let's look at the basically I mentioned about 5G 5G network, but the more focus actually is on the RAN part. There are two reasons for that. One is that I myself is more well versed with RAN. Another thing is that the the typically lot more people are actually are working on the RAN side as far as engineers and academic institutes are concerned. Okay, so uh, let's look at the typical hardware and software setup. So this is the simplest uh, setup. This is SDR based, mostly VRAN. So we'll find that the OAI core 5GCN is again getting implemented in a server. It can be in a same machine or it can be a different machine depending upon the requirement or the use case. And then the RAN part is basically the monolithic one without split 7.2 is all everything gets implemented in the Ubuntu. So you have got both the F1 is split and a CUDU type of architecture. You can actually run CU and DU on separate machines also, right? So depending upon your requirement, and then the radio part, all that actually is gets implemented is by a SDR. So the B210 USRP it does is one of the very popular and the lowest cost SDR which supports 2 by 2 MIMO. Okay, so the interface between the RAN and the software part of the RAN and the radio part of the RAN actually is through a USB 3 interface. So the SDR gets connected to this guy, the RAN part through a USB 3.0 interface for B210. Of course, there are some other SDR which have got other interfaces also, but let's to keep things simpler, let's just say that the B210 talks to the software part through a USB 3. Okay, any query or quick questions? Okay, so here little more detail about all the three actors. So basically what is the typical hardware software setup? So you will here you can see that the OAI 5GC, some of the few means main uh, modules are shown here, and then the RAN part, the all the layers are there, and then we have got the typically Ubuntu 22 and 24. Most of the people are using it, right? And then the internet, external public network is connected, right? And then we have got test mobile with test sim. So it can be actually COTS mobile or it can be a Quectel module. So Quectel module basically is a module which does not have any which typically is a sort of a bare bone the modem chip, uh, the Qualcomm, and that can also connect to the any of these network. Okay, and then the here the SDR part is shown. So there are other SDR families. B200 is actually one by one, and then B21 2 by 2, and then there are other SDRs which may have Ethernet or PCIe interface also. Okay, any queries on this slide? I think you might be noticing that, and I should tell you that this slide looks uh, a little, I would say, doesn't look very clean because I created something first through AI, and then it was not able to understand 3GPP semantics. Then I had to myself uh, make modifications uh, by doing some quick dirty cut and paste work. Okay, yeah, this is a little more detail. Again, this is similar, so let's uh, only this thing, the one interesting or something which needs to be mentioned here is that you will find that the GNB part is getting implemented in one machine, one setup on Ubuntu OS connected with a SDR, and NRUE also is getting implemented in another setup connected to another SDR. So this plus this becomes the OAI RAN as well as OAI NRUE, and then this the COTS mobile can connect to this, or it can connect or the Quectel module. Okay, yeah. So the hardware requirement, I think all these are typical, very basic requirement as laid out by the OAI 5G people. The Intel CPU they recommend more than 12 cores, Intel i7 or i9 with at least 16 GB RAM. Again, this is not very hardcore. This simply means that if you want to basically support or want to achieve higher throughputs, then you should go for a more powerful machine. But doesn't mean that you cannot have basic functionality, lower throughput functionality on a lower configuration machine. Okay, so they only support USRP family of SDRs, and then selected ORUs already we discussed, Benetel, VVD and Lekha. Software typically more Ubuntu greater than 20. There are quite a few software tools, drivers. Real-time kernel is required for low latency file layer operation. Right, so we'll not go much into detail of the SDR. It's just enough to say that this is the very popular SDR, software defined radio, used in so many other use cases in education as well as in so many other radio related, GNU radio and so many other applications. So that's how it looks like, the B210. This is the B210. This is just with box. So I myself have got a B210 without box. Okay, so any questions till now? Any questions are there? Okay, so we'll move. Yeah, since we have already looked at what are the specification of the GNB part, let's look at NRUE part, little more details. These are the typical. So they actually claim, and I don't have any reason to suspect their claim because I've been seeing them earlier. It was not really operating with the third-party commercial GNB, but I think I'm sure that recent times they have been able to do that, so that's why they have put this claim that it can connect to a third-party commercial GNB, supporting multiple bandwidth, different architecture, ARM as well as x86. This one is interesting. So yeah, nothing much to talk about UE part. The LTE also they support, but I don't think many people these days are using OAI for LTE. Yeah, coming to the L1 capabilities, the uh, so they anyway everything is standard compliant. So they claim up to 1.4 Gbps downlink and 40 Mbps uplink with commercial UEs, and they anyway test with the typically with the Quectel modules and as few of the selected COTS UE. So based on the multi-threading threaded processing, FFTs are there, all that anyway. They anyway do a lot of benchmarking and CICQ, CICD testing is there to validate the performance in real time. So there are different modes of the physical layer modules. So one of the most important module actually the mode is RF SIM. So RF SIM basically it's basically the fully software uh, the the L1 part plus it what it is not having is uh, the if suppose somebody does not have radio, right, somebody does not have SDR, then you still want to do some simulations to test your modules or do some quick end-to-end testing at the software level, right? You want to check the performance in the presence of AWGN and fading and so many other things. Suppose you want to explore NTN, both the GNB side as well as on the UE side. So the RFC mode of the L1, both on the GNB as well as on the UE side, is the answer to that. So it simulates real world radio conditions, including the physical layer modules anyway. So it totally avoids the over the air transmission. And in this mode, basically, you are still connecting to a real core network which is running. Okay. And through basically GNB to NRUE, everything you can do it in a simulation mode. So one, for example, you can run everything, core network, GNB, NRUE, everything in one machine. Okay, suppose you have got a powerful machine, you can run everything in one machine. So zero expenditure. Will not go much into other modes. The RFC mode, as we already discussed. So everything is basically real in the sense included. It's not anything simulated. Connection with core network or communication, NAS procedure, PDU session, end-to-end IP traffic, all the N3 interface, everything, right? What is simulated is these parts, the radio part. Okay, so very useful, and any of you can actually start use this RFC mode without spending a single penny, right? So yeah, then NRNTN, which is these days quite popular because lot of people are actually lot of work R&D work is going on, and in academics also a lot of people are doing uh, exploration and research in NTN, and it's supposed to be a very even my own gut feeling is that the NTN is going to be a very uh, revolutionary use case as far as 5G is concerned, because it takes care of the coverage in remote areas, and even has capability to connect lakhs of IoT devices also. So there are so many use cases, We'll not go into that. Sufficient to say that NTN is a very important feature, and for anybody who wants to work in 6G should know about NTN. Okay, so it supports Release 17 feature for GEO and LEO satellites. There is certain new SIB has been defined. All that things are there. So this particular UE frequency offset, all that composition, because Doppler and all that is a very big thing and very high delay. So there are certain assumptions which are made and design considerations for NTN, including the HARC which are there. So RFC mode, there the channels, the actual satellite channels can be simulated, right? So this allows experimentation with satellite-based network to validate different NTN features and test end-to-end scenarios without requiring satellite hardware. So as you know that till now anyway there is hardly any mobile UE side which supports full speed 5G capability for NTN, but using the RFC mode and NR-UE implementation, you can pretty much have an RF implementation for NR-NTN as well as SDR based implementation also, both on GNB side and NR-UE side, right? So this is what which has been shown here. So this anyway is same SDR based or RFC mode. This is again RFC mode or SDR based core network, and then this particular part can be replaced by the some commercial traffic emulators from companies like Agilent and R&S, or in RFC mode you can do it in RFC mode also. Okay, yeah. So the third party, there is one advanced feature is there. The OAI 5G RAN has been interfaced by some third party acceleration support. For example, NVIDIA has got enabled L1 implementation on GPU. Similarly, Intel and AMD also are having some implementation, Flex RAN, and I think something else is also there, and even AMD is also having. So all that basically people have done that interface, and so typically they will, this is the thing, say they will replace the L1 of the 5G RAN with the, for example, NVIDIA. Okay, so the interface between DU high and DU low is through NFAPI. All right. So similarly for the Intel and AMD based, I think here some part is there in software OAI 5G RAN, and some part is offloaded to the Intel. Similarly for AMD, I myself don't have much of idea of all these things because I have not really used these things, but these have been found to be working. Yeah, so another thing, I think the side link, NR side link, which you always see in the specification, but hardly anyone actually uses that, or not many companies are doing any commercial implementation of the side link, which can be actually very useful for certain use cases like disaster communication or ad hoc networks. So we will not go into much of details. I myself have not used it, but they do support different modes, mode 1 and mode 2, where mode 2 is more UE to UE, while mode 1 is, I think, under GNB coverage with GNB managed resources. So this is the information or detail from OAI side website. Yeah. So now till now what we have seen is that the various uh, interfaces are there. So till now we found out, we talked only that DU to RU we used the SDR, but as we already mentioned, the OAI 5G RAN also supports split 7.2 in the fronthaul. Okay, so that has been found to be working with uh, certain vendors models, Manetel, VVDN, and Lighton. Yeah, there is. I found some information about. I was myself not so much aware about channel emulator, but looks like this channel emulator is quite interesting. They have developed a modular channel emulator, so you can create realistic channel conditions for 5G and 6G research, because in 6G you have got this so many the advanced features which require a uh, to basically simulate a wireless channel sensing and communication, and then there is another so many features are there. This is very interesting. I myself have not used it, would like to use it. Are you people there?
Yeah, Nitin.
Okay.
Yes, yes.
Yeah, by any chance, have any of you have used or tried this the channel emulators? Okay, here mentioning in very quickly what are the debug tools for development. So you can do, since if you want to do any development, any feature change, implementation, or add new feature or make changes, obviously you will break the code, you will need to debug. So you need debug tools. So there are quite a few tools available. The code level, various type of the logging is possible, warning, error analysis, debug. The file layer specific log uh, is uh, supposed to be there to some extent. Again, I have not myself used that, but it is supposed some sort of that IQ layer recording is there. Something is there which is not available or not working. Again, you pardon me because this is information is almost 1.5 year old. Some maybe now it is all enabled. So all this network protocol log, Wireshark, PCAP, and all that can be looked at. You can generate wireless PCAP for F1 split or the communication between core network and the RAN. All that you can see. Of course, you cannot see the same for the file layer, right? So this is just to show that different level of uh, the logging you can put in configuration file. Yeah, different debugs are there, tools are there. I think I have used actually few of these tools. This is a mold. Basically, you can see each and every process graphically and visually. Then the GUIs are there. Something like basically you can look at the at L1 level the your eye diagrams, the LLR graphs, frequency domain, the time domain signal, all that. The IQ player, same thing I talked about, is that you can record slots received by the USRP board. Those are typically final IQ samples, and then you can record it, and then you can replay it offline, and then you can uh, send it to use it for different purposes. Again, there is one more, some more uh, tools is there, OAI time analyzer. I think I have not used this one. Then there is this telnet server. You can change and some parameter by doing telnet and all that. There is certain syntax. Will not go into those details. Yeah. So the one important logging part anyway is the protocol logging. So the PCAP file formats you can generate. I will show you those PCAP format. Okay. So till now all good. Any queries or questions? Any inputs? Okay, I will move on. Yeah, so what all you can do with it? That is, I think, the very important question, because fine, it is there, but what all you can do? So there are a lot of things you can do. So you can actually set up real test uh, the desktop live networks. You can connect some mobile, drones, camera, okay, multiple UEs also. You can do a lot of experiment related to the physical layer, replace some algorithm module, add wireless feeding channel in RFC mode, for example. Or suppose you want to connect it to a feeding channel emulator, commercial feeding channel emulator, all that. The MAC scheduler, or you want to change any other feature of L2, L3, you want to add some new feature. So the advantage of all this platform is that these are future proof. I mean, these open source code bases are evolving, and very quickly the 6G and all that will start appearing. So already mentioned that it works in both over the air and software loopback mode. You can look at various logs and do a lot of debugging, specifically for academics. So we'll not go into each and every detail. You can just go through. Here I mentioned how can students, say for example BTech students, can learn. They can first start public network. They can connect and they can see what all details are there, right? Change the parameters and then see how things happen, what happens, do some debugging, quick debugging. And then now this second one is they can do actually on the 5G use case lab. And then if they want to go at a higher level, for example, if they are doing some main project, for example, any BTech student, their major project, or for example, any MTech student or PhD student, they can do a lot of things. They can actually create some new ideas, validate those in the end, show that it is giving better performance. All that is possible. Again, we'll not spend much time on AI RAN, but yeah, lot of things are possible because you have got everything. You have got each and every log. You can run it in real time. You have lot of data available. So all that you can use for AI RAN. will not. There are some use cases mentioned about AI RAN. Again, some of this information uh, is just happening. People are doing lot of these things. So main consideration is that whatever you are doing, for example, in a real network, you have got everything, real traffic, real radios, so you can actually check the performance whether by using certain AI RAN feature. Suppose you did something AI for RAN, or some new thing you did, whether you are getting better KPIs in a live network, whether higher throughput is coming, whether the stability is improving, any optimization is happening in terms of functionality, or the durability, or the 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 basically the load is coming down, right? Yeah, so anyway, this AI for RAN, there are since AI for RAN is actually was is more of a helper type of thing. AI is used for as a helper for improving specific functionality. For example, for MAC scheduler, for handover tuning, blur prediction, anomaly detection, all these things. Some of these things are already actually happening. People are doing in academic institutions. Yeah, again, I'll not spend much time on this. Yeah, just to summarize what all the skills which are acquired by this real setup is that lot of practical experience, implementation of various algorithms, RF engineering, signaling interfacing, core network concepts, network security, because you can change any of the network security uh, parameters, or you can since you have both NRUE as well as the GNB, you can implement some new security algorithm and can try out measurements, AI related, NTN related, monitoring, performance analysis, integration. To summarize, whatever you can do with an 5G open source network, it is closest to working in an industry which is developing a commercial cellular network, right? Yeah, I think I'm just telling what all things can be done. Yeah, so I think now I am coming to the last segment of the our talk. Is I will be here. I am actually showing uh, the way I am using this setup myself. So basically, uh, say this one is, you can see that this is the GNB part. So on one machine, Intel i799 machine, you are running GNB CUDU. Core network is also being run here, and through Wi-Fi it is connected to a internet. Okay, and then there is this B210, right? And then you can actually, if you want to run everything in RFC mode, then you can use the Ethernet cable or Wi-Fi. Or suppose you want to use SDR live network with NRUE also implemented in the software, then you will use one more SDR. So the NRUE is running in software and it is connected. It is emulating the functionality of a mobile by connecting to a SDR. Okay, now the the hardware requirement for the NRUE can be somewhat lower. Now this one is the most typical combination, and I also use it most of the time. This is the type of the setup which I will be using. Okay, so everything is clear, not till now? Yeah, so this is just one uh, basically a picture from my own setup. My table and my setup looks exactly like this only. So this is my B210. This is my test mobile, COTS mobile. This is OnePlus device. Then all the core network and RAN is running in this machine in Ubuntu. Okay, this is again I will skip this one. Is I am showing that SRS SRS RAN 4G setup, UE as well as the RAN part. Yeah. So coming to the demo, yeah, I just wanted to uh, pause here and then wanted to check if any queries are there at this point of time. Hello. Uh, can any of you please acknowledge if you people are able to hear me?
No, I
Okay.
think.
Okay. So is everything clear till now?
Yeah.
Okay. Thank you. Either my presentation very is not clear, or you people are too intelligent that you are able to understand everything. Uh, my guess is that you people are very intelligent. Okay. So coming to the demo setup. Yeah. So I'm running everything core network and RAN together. So this is the exact setup I am using. 13 Gen processor, 16 GB RAM, Ubuntu 22. Source code I have built myself for the RAN part, and core network I am running in Docker mode. I am using I'll be using USRP B210. This is the configuration for the demo. 40 MHz profile, 30 kHz spacing. This is typical N78 basically, band 78, which is very popular even in India also. Uh, Geo, this is one very popular band used by Geo. 106 RBs, 2x2, single UE setup. So I will be using single UE, but you can use multiple UEs also. Then 5G COTS mobile. So let me just show that in Visor. I am actually, this is the mobile. Are you able to see the OnePlus mobile?
Yeah.
I am showing it in
Yeah. I
yeah,
can see that.
in the Visor, through Visor. And then additionally, what I'm doing is that I am actually running a COTS UE protocol logger, which is a in-house developed by us, the COTS UE protocol logger. So this is the overall demo setup. Let me know if you have any questions on this setup. So this is the same thing. Core network and RAN is running here. This one is all monolithic part. I'm not running any CU/DU split or F1 split. I'm running the monolithic part. Then this OnePlus mobile is there with test SIM, and then additionally, this is a new thing. I am actually you will see that this SDR B210 is connected to the host through a USB 3.0 interface. There is another USB port which I am using to connect, because I want to get the mobile side log or the protocol logs, because I am running this Mobisync UE logger. Okay, so is this clear? So this is also running here on the same OS, Ubuntu OS. So that is clear, na? Yeah, this is the same setup. This is what I am doing. Okay, so yeah, I think we'll skip this part, and then I will now move to the core network. So this is the core network. You are able to see the Ubuntu terminal, right? Hello? So I am actually bringing up the core network in Docker mode. Okay. All right. So what I am also going to do is that I am going to I am just initiating the logging the AMF and UPF logs. Okay. Sorry, I used a, yeah. Okay. So now our core network is up. Now next we will bring up the RAN part, the NR-soft modem. Okay, so you can see that we have got a configuration file for B210 and band 78 FR1 containing a specific configurations for that. All right. And then before that I want to do one more thing. I want to initiate the pcap dumps. Okay, and then now I started the now my RAN is also started, as you can see. Okay, it is just waiting, it is just sending, it's already transmitting. Okay, and then now I will move to the mobile. Okay, let me show you. Okay. So this is the SIM one. Okay, and the access point is also already enabled. So this is the test SIM in SIM 1. Now what I am going to do is that I am going to remove it out of the aeroplane mode, and now it is connected. You can check that it is connected. I'm just running some simple app. It is connected to the 5G SA at N78. Okay, this is the RSRP and RSRQ, and then I will put this in NR only mode. This particular setting is important, otherwise the link will break after 1 minute or so. Now what I'm going to do is that I'm going to start some traffic. Okay, now there is something I want to show you is that I will start our mobile side logging tool. So this is the uh, COTS mobile logging tool. This is developed in-house by us. So we can get all the MAC RLC PDCP log, all the uplink downlink channels, blur, CQI, BSR, RLC, PDCP, RRC and NAS. All these the RRC OTA as well as NAS. NAS logs are the decrypted ones. Then some of the L1 specific means the SNRs and cell search related information. And then already by default it is Wireshark mode, and then I will start logging. Okay, I don't know, for some reason it has stopped. Yeah. So are you able to see now? Hello? So now basically I am showing now all these few of the KPIs starting with blur. So you are able to see now that blur. I am actually moving the system, the mobile little far. So I start seeing the blur, and then this is the DL SNR at L1 level, the ULMCS and then DLMCS. This is the PDCP level throughput. Now for the ideal situation, the PDCP throughput is very close to the application throughput. Okay, I will just stop this now. I just stopped this one and just wanted to show you that we can look at the RRC messages. Okay, at present since I started this logging part late, so I am seeing only measurement report. So what I am going to do is that I am going to put the device in aeroplane mode and then start this tool again so that you can see the you can see the right from the beginning. Are you people with me? Okay, so at present nothing is there because mobile is in aeroplane mode. Now I'm just bringing this out of the aeroplane mode. Okay, so things started and it got connected. You can see, right? I will stop this and now I will just show you first the this log. So we have this filters defined already. You can see here mib zip, each and every uh, parameter you can see here. All this RRC setup, request setup, complete authentication, all that is there. Basically all network entry messages you can see here, right? So this one is at the mobile level, COTS mobile level. So each and every parameter you can see here, including cell search, right? Multiple beams and cells. Then we have got NAS messages. They are also decrypted ones. So these can be useful for advanced testing of core network and RAN. Then we have got the MAC messages, all the PDC, CSID port related to CQI, the PDSCH stats, ULTB stats, PHY channel, uplink channel and downlink channel, PUSCH, PUCCH, everything is there. Then I've got PDCP and RLC also. I defined filter, but for some reason I am not able to see that filter. So anyway, so let me so basically all the KPIs which you are seeing, so for example here you can see that the PDCP level information is there. So some of these KPIs which I am having here, for example this I am getting it, this information from our dissectors, whatever the messages which we are, logs which we have extracted from the mobile. Similarly downlink blur, all this thing is coming from the these various logs. Okay, so now this part is done. Now what I am going to do is that you can see that the GNB side mobile is connected and you can see the traffic flowing through the downlink and uplink blur, right? You can see that downlink blur uh, is almost 0. There is very little uplink blur. And then what I'm going will do is that I will stop this guy GNV and then I will stop this collection of the PCAP file. So we have got this, the recording of the PCAP file of the uh, between core and GNB. Okay, so I will open that. Okay, so this is the PCAP file. right? So here you can see that these are the uh, between N gap between core network and RAN, all that HTTP and the 5GS messages are there, right? So these are the information which uh, every RAN engineer uses, right? So all that information is all getting captured, correct? I think here all this whatever communication is happening between mobile and core network also, all that is also is getting captured here also. Okay, and then I want to show you, let me stop the core network part, and then I will show you the, oh my god, UPF logs have not got, okay. So you can see that the since I stopped, so it got deregistered. So these are uh, the core network logs, right? Yeah. Hello, are you people with me? Hello. Hi, Vishnath.
Yes, sir.
You are there. Okay.
Yeah.
So, yeah, so you were able to see the demo, right?
Yes, 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 sir.
Okay. So, fine. I think I'm more or less done. Yes, there is
Yeah.
some stuff which I will just skip. Any questions you have?
No, sir. No, no, nothing else.
Okay. Yeah,
Yeah.
I think this is some information I will.
Ah,
Yeah, just the key message is basically that the open source tools, open source code basis network enable means real deep understanding and full control. So
yes.
they are actually useful for research, prototyping, and creating some projects for various levels. Again, it's never easy to use open source. One is to struggle. There is certain ramp up time. So
Yeah, yes, sir.
yeah. So main thing is that it is low cost. We have already found out that the when it comes to the simulation mode, then you are not paying anything at all to learn so many things.
Mm,
Yeah, I
yeah.
think I am done. Any other any other query or questions you have for me?
No, sir. I have no questions. It was a good demo, actually.
Okay, yeah. Thankfully, everything went fine.
Yes, yes,
Yeah,
sir.
okay.
Uh,
Yeah, I think I will stop at this point of time and thank you so much and thank you every other participant for joining. So,
Thank you, sir.
yeah,
Thank you so
thank you
much.
so much. Yeah, thank you. Bye bye.
Yeah.